Good morning, everyone. So I am talking today about cognitive computing. The name of my talk is Domo Arigato, Mr. Roboto. I do not speak Japanese. I copied that straight from Wikipedia. This is also not a talk about robots. Like I said, I was talk about cognitive computing. Now, my slides are available online, snugug.github.io/Mr. Roboto. That slide link will be available at the end again. Snugug is the bit that's important. That's who I am on all of the internets, on GitHub, on Twitter. You can find me there. So let's talk about the world of cognitive computing, shall we? This is Pepper. Pepper is a robot built by SoftBank, a Japanese company. Pepper is designed to be one of the world's first human-computer interactive Android type things. And it's using the power of cognitive computing to make this interaction between humans and computers a little bit more natural, a little bit easier, something that's not like the programming that we do every day. Well, I guess if we're going to talk about cognitive computing, we should probably define what cognitive computing is. So cognitive computing is a new field of computing. The types of problems that cognitive computing can solve are unlike really any other problems that we've been able to try and work on before. It's for working with human complex problems. So the type of problems that we're normally used to solving in computer science are not really human complex problems. Human complex problems being problems that really require a human to solve. They're usually things that can be solved with just math or just data analysis. But cognitive computing aims to be able to solve problems that otherwise we wouldn't be able to do. And it does this by using machine learning and artificial intelligence. So not a single path towards a single solution, but rather more probabilistic solutions to problems, which is a very different way of thinking about computing than what we're normally used to. And it works with human natural input and output. So think instead of putting in numbers and getting numbers back, or putting in keyword searches and getting keyword back, think rather putting in long-form text, like whole web pages, and being able to answer questions on whole web pages without first converting it to anything. Or speaking into a computer and getting things back, and having the computer be able to understand speech, or audio, or video, or images, and be able to output audio, video, images, other forms of long-form text. This is the type of problem solving, the type of solutions that we can do with cognitive computing, which is why it's this new type of computing and this new type of problem solving, which I think is really cool and lends itself to really interesting new types of applications. Yeah. What does that mean, though? So, I bet you all have used a cognitive application, if not today, recently. Who here has used Google Now, or Siri, or Cortana? Yeah, those are all cognitive applications. They're a pattern of cognitive application called the personal assistant, and it's one of the patterns that we find at Watson people use all the time. Let's break down what that personal assistant cognitive application is. It's speech in. That speech gets transformed into text. That text is then run through usually what we call a natural language classifier to figure out what the subject of the sentence is, what the subject of that text is, pull out the individual pieces, then it runs its business logic underneath it to figure out, well, if you're talking about the weather and you have your location, go and find the weather of that location, and then runs a speech to text to transform that into synthesized speech and then tells you what it is. Or if you're doing a Google search, or a web search, it will go and it will find what that is and possibly pull back, here are the results for you. Or look in Wolfram Alpha and kind of pull out those individual pieces. So these are all different types of speech input and then business logic and output. So not everything inside of a cognitive application needs to be cognitive or needs to fit this cognitive paradigm, but the application as a whole becomes cognitive when we provide it with these types of, and use these types of different cognitive input and output to work with it. That's what I wanted to say, yeah. So let's talk about, and let's see what some of these examples are. Let's play a little bit. I like pepper dancing. Pepper's fun. So the first application that we're going to talk about is this little thing that I built. It's a little tiny Chrome extension using Watson's text analysis tool. And what it does, it's a Chrome extension for GitHub, where as you're typing, it analyzes the speech that the actual long-form text that you're writing in the comment box. If it finds that the text is negative, if the content of your text is negative, it switches the comment submit button from green to red. And if it becomes angry, it disables the comment button. Right? That's pretty fun. So what's awesome about this, and one of the reasons why I'm talking to you about this, even though you might not be able, or you might not think, well, this is probably really super expensive and probably something that I get access to because I'm Watson. This is built with a single publicly available API that you can go and use right now. And Watson isn't the only group doing this, but we happen to have a whole slew of cognitive APIs that you can go and use right now by searching for the Watson Developer Cloud. And this is one called Tone Analyzer. So what winds up happening here is as you type on key up, the Chrome extension sends all of your text off to a little tiny server I made in Node. That runs through Tone Analyzer. It comes back, and Tone Analyzer splits your text into one of 3 different tones: happy, negative, or angry. And if negative is 1 or above, I tell you that you probably shouldn't send that. And if angry is 1 or above, I disable it. Usually you're angry and negative, but you can be negative without being angry, which is why it's kind of that 3-layer thing. So this is the first type of cognitive application you can build. The second one gets a little bit more complex. So this is something I wrote called Babelfish. Babelfish, for those of you who don't know, is this little weird, it's the weirdest thing in the universe. You put it in your ear, and then it translates all text, or all speech into other speech. It's from Hitchhiker's Guide to the Galaxy. But Watson has 3 APIs, a speech-to-text API, a language translation API, and a text-to-speech API that, when combined, you can create a Babelfish. So what this is going to do is I'm using get user media to get text input, or speech input. It's going to go run through that speech-to-text algorithm. It's then going to translate that text using text or language translation. Then it's going to spit it out in that native language. Unfortunately, German isn't supported, but French is. So what we're going to do is I'm going to say English. I'm going to go to French, but I'm going to do it not on my speaker notes. And then, hello, JSConf. Live demos are always fun.
Qui intervient juste.
Close. Let's try. I guess JSConf isn't something that speech-to-text understands. So let's try something else. The breakfast this morning was fantastic.
Le petit déjeuner ce matin est fantastique.
That's a little bit better, I think. So what these APIs look like under the hood is the way that what you get back from speech to text is you get a confidence meter. And this is where cognitive applications sort of differ from normal APIs that you may wind up working with. Speech to text is a little bit iffy. It's working off of probability. It's not working off of absolute confidence. So what you get is you get the translated text, but you also get a confidence meter from 0 to 1, 0 to 100%, basically. And that is going to tell you how confident it is in your results. The first one, not so confident. This is pretty confident. This is more or less spot on. Then language translation, just as a one-to-one translation. Translation happens between different domains. So you could have right now there's a news domain, and I think there's a medical and a travel domain. But one of the great things about this is because cognitive computing is based off of artificial intelligence and machine learning, you can learn, you can train it, you can have it understand your specific domain. So if you wanted to create, let's say, a food application, you could train these APIs, you can train cognitive systems to understand the domain of food. So you don't have to know necessarily what a croissant is in English or French. You don't have to know what those words are, but you'll be able to translate them using the translation by training these applications or these APIs. This I'm just using a standard news domain. And then text-to-speech synthesizes text in one of a variety of different languages. And that just takes whatever text and goes straight off. So it's cognitive input, human natural input, with language translation, which is trainable to understand the different domains you're working in. And then text-to-speech at the end, which is a human understandable output, which makes this whole thing a cognitive and a kind of new way of working and interacting with your user. And there are really only 3 APIs being used here. The final bit that we have is a little bit more fun. It's cognitive computing. So the first example that we showed is something that you can build today with a single API. It's a very simple example of what cognitive computing can be. One API, one natural language text input goes off to a server, comes back, you do stuff. The second one, a little bit more complex. There are 3 APIs being used. One of them goes and turns speech into text, then it does stuff in the background and gives you speech out. Be able to hold full conversations with other people that you otherwise couldn't. But that's also available as 3 public APIs. This is a little bit future state. It's available now, just not as APIs. Chef Watson is something built on what we call Watson Discovery Advisor. But what it really is it's a system for understanding connections and being able to find connections between things that you wouldn't otherwise be able to see. In this case, food. So what we've done here is we have ingested all of the recipes that Bon Appetit magazine has written. We have ingested all of the chemical makeup of all of the ingredients. And let our artificial intelligence and machine learning and deep learning kind of do its thing on them. And what you get out of this is you get food pairings and recipes that you wouldn't otherwise know or wouldn't otherwise be able to see. So one example of this is when we talk about food and we talk about cooking, normally the foods and the recipes that we have, those ingredients go together. I guess the police don't like me talking about food. So food and recipes, they generally go together, and the ingredients in recipes generally go together because they grow together. They come from the same region of the world. But things like apples and olives don't grow in the same place. But it turns out that when you look at the types of recipes that they're used in, and you look at their chemical compounds and how other things relate to those 2 ingredients, apples and olives turn out to pair really well together, even though it's something you would never think to pair together because they don't grow together. And what cognitive computing and what Chef Watson is able to do is it's able to find these underlying connections. It also has applications in other things. Think law enforcement. We have this demo where we ingested all of Wikipedia, and you ask it questions about Wikipedia, like what are the planets in the solar system? It's able to tell you what all the planets are with all the evidence and all the confidence. So you can actually trace back all the evidence and all the different pieces that connect together. This is how cognitive computing is a little bit different than normal keyword search, is that you can actually see the full evidence tree of how you got somewhere. So let's build a recipe. Chef Watson starts with ingredients. Someone yell out an ingredient. Bacon. 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 And it starts to think. We know it has bacon, and then it makes some suggestions for us of other types of ingredients that are known to pair well with bacon. Smoked turkey, pecorino romano, and some navy beans. So does someone else want to throw out an ingredient? Soy sauce. Dark soy sauce, dark soy sauce. Undefined dumplings. Yes! I think Chef has decided to pair bacon with more bacon. Anyway, so cognitive computing, and specifically Chef Watson, it goes beyond just ingredients. We can talk about dishes and styles as well. So let's choose a dish. Let us do a bacon and soy sauce Bloody Mary. No. How about a Caesar salad? And get rid of the Bloody Mary. Maybe we won't do a dish. Or a style. Back to school. There we go. So, back to school bacon dumplings. And then if we load this up, what we wind up seeing is we wind up getting a brand new recipe that's never existed before. So Chef Watson didn't go do a search on the internet to find back-to-school bacon dumplings. What it's done is it's used the corpus, used that training of all of those recipes, and used the training of all of the different ingredients and the chemical compounds of all those ingredients to come together and build a new recipe for you, build a human output recipe for you based on other things that exist, but this has never existed before. This is kind of, to me, the power of cognitive computing. It's being able to not replace humans, but empower humans to find connections and be able to interact with computers in ways that they would have never been able to interact with before, and ways that you wouldn't have been able to see or use before. And the best part about this, for me anyway, I'm a little bit biased because I work for Watson, but all of these APIs that we have are for free. Chef Watson you can go play with right now. And we're not the only company doing it, which is awesome. Artificial intelligence, machine learning, deep learning, the foundation of cognitive computing has gotten to a point where it's now coming out of research. For the first time, really ever, these APIs, this ability to really dive deep into our data beyond what we traditionally think of as big data, dive deep into human understandable content, is something that's available for everyone to start using and everyone to go play with now, which to me means a big win for the future of applications and the future of our work. And I would have been better had it worked the first time. Yes. To me, that means it's a big win for us, and it means that it's a big win for our users. Like was said, I'm part of the design team. I'm an engineer. I'm a UI architect on the design team at Watson. So to me, what these provide is they provide a way for us to design the next generation of applications. Screw your JavaScript frameworks. Use whatever one you want. To me, that's not what matters. I appreciate that I'm a JavaScript conference and I just gave an entire talk not talking about JavaScript. But this is what's important. Our users are what's important. And cognitive computing and cognitive applications will provide us with the means of producing the next great user experience. Not React, not Ember, not Angular, not ES6. Those are tools to build them. But cognitive computing is what will let us actually create them. Thank you. Okay, can I have the slides back again? Those are the links. That's the link to the slide deck. Links to all of the source code for those first two applications are available online. I'm Snugug, that's my website, that's Twitter, that's the slide deck again. So all the links to everything are available online, including all the source code for all the applications. Thank you.
Thank you, Sam.